Okay, we're going to be doing lead code 566, Reshape the Matrix. So it may look a bit intimidating if you're not used to working with matrix related questions, but it's very easy. So in MATLAB, there is a handy function called reshape, which can reshape an M by N matrix. This is usually rows by columns, into a new one with a different size, row by column C, keeping its original data. You are given an M by N matrix called MAT, and two integers R and C representing the number of rows and columns of the wanted reshape matrix. The reshaped matrix should be filled with all the elements of the original matrix in the same row, traversing order as they were. If the reshape operation is given parameters is possible and legal, output the new reshaped matrix, otherwise output the original matrix. So this is when you look at this part here, right? Should be filled with all the elements of the original matrix in the same row traversing order. It means that there are instances where we could be given a row by column, these values of the new shape that they want, whereby it can't work out, right? And for those instances, we have to simply return the old matrix, right? Otherwise, you output the original matrix, right? So the way we're going to solve this is we're going to first check if the number of values here is equal to the number of possible values in the new matrix, right? And we simply do row by column. If row by column is not equivalent to row by column here, then we simply return the old matrix. So that's the first thing we're going to do. Then we're going to put all these values into a queue, right? Because that will be able to maintain the order. You can use a queue or an array, and then we'll get values from the left of the data object we've used and place them into our new matrix. And we'll obviously have to initialize a new matrix for the output. We can call it output matrix or whatever, right? So let me draw it so that you see what we're saying. So say we have such a matrix, right? And then this is the row, and they want us to do something like this, right? And this is our new matrix. We can't put this in here because the new matrix is too large, right? It will have empty spaces, right? Or we have something like that, and they want us to put it into a matrix that is like this. We still can't put this matrix values into here because there'll be some missing, right? So the first thing we'll have to do is test, right? For example, if it's like this, and they want us to put it into a matrix like this, then this will be possible, right? So this will be row 2, column 3 into a row 3, column 2, right? So after we've checked that to make sure that it's possible, we get, so this is the old one and this is the new one. We get the values from the old one and place them in a matrix. That's how we maintain the order. I mean, into a queue, right? And then we pop left from the queue. In Python, you use pop left to pop from this side, right? And the reason why we use a queue and not an, you can use, there are two ways of using a queue. You can use a queue using a list in Python, but it will take on time. But if you use a dequeue, the function dequeue, it will be an actual queue, and you just pop left. An alternative is to insert these values into an array, and then you move from the left, adding here, right? But we're going to just use a queue. And then after that, we return this. So some people usually forget how to initialize a new matrix, and I'm going to show you how to do that as well. right? We'll initialize a new matrix with zeros. So now let's get into the code and do this, right? Okay, so now to write it in code. So first thing we have to check if the new matrix can fit all the values of the old without having any extra space. This is very simple. It's just going to be, we get the old rows, which are going to be, let's do it, old rows and old columns. So the old number of rows will be the length of the old matrix, and then the old number of columns will be the length of the first column or the first row, right, which will be at this position, index 0, right? So now that we have that, we compare, right? If old rows times old columns, we're trying to get the number of values, right, does not equal to our new rows times column, because remember these are new row and column, then we simply return the old one, right? Because it means it's not possible. Maybe this is larger or this is larger, right? We don't want any spaces in our new matrix either. So it's possible, so we create a queue which will put in our values from the old matrix, right? So we'll call it I'll call it store queue is equal to collections.dq, right? So that's how we get our queue in Python. And now we initialize our output matrix, right? So how do we do this? We'll call it output is equal to we use list comprehensions, so we're going to first initialize the columns, which will be 0 for, that's just like a counter, in range C, right? And we do this for dash in range rows, right? So what this does is, for example, if our R and C are, let me show you what this code does. So okay, so if our R and C, if our R is 2 and our C is 2, what this code here, output, what it does is it first initializes zeros in the columns, say 1, 2, 2 zeros, and then it does it twice, and this becomes our matrix, right? So it does columns first, and then it goes rows in the row direction, right? Okay, so now that we know that, so next up we traverse the old array, the old matrix called mat, and add its values to the queue. So how do we traverse? For row in range old rows, for column in range old calls. Then it will be store queue dot append mat row, column. And that's it, right? Now we traverse the new matrix called output and add from the queue, right? We use a queue because it's first in, first out, right? So it will maintain the order. So how do we do this? We don't want to use this same, you could initialize them to 0 and then reuse them. But if you use these again, this variable, in Python, it's initialized like a variable that whose scope is here. So it's better to use new ones. So for I in range, row, and then for j in range, column, right? We are going to do output at I and j is equal to store q dot pop left, right? So that's how we do it. That's how we do the queue in Python. So after this, we'll have initialize our new matrix in the same order as the old matrix. So it will have all the values in the right order, but arranged differently, right? So here we simply return our output, and this should work. Voila. So that's how you deal with this. It works. All right, so this takes an it takes an of length of matrix times row of matrix times column of matrix. The space of the extra matrix is, we don't consider it because it will be 2 times the old matrix, but that's in the large scale of things, that's not big, you know. So I got the initialization. Geeks for Geeks has a good explanation of how to initialize a matrix in Python. So yeah, so the space complexity is of, say, m by n, and that's the space complexity. The time complexity is still O of m by n. So yes, thank you and bye.